Welcome student. Today we are seeing Maharashtra State Board 12th chemistry exercise solution और आज का हमारा चैप्टर है चैप्टर 6 that is chemical kinetics. So let's start. So first question is the rate law for the reaction AA plus BB gives P. Its rate is equal to K into concentration of A into concentration of B. The rate of reaction is doubles if, and these are the options for this question, and the correct option is option B, that is concentration of A is double and concentration B is kept constant. So let's see the explanation for this question. Explanation: given that rate is equal to K into concentration of A into B, the equation implies that the rate of reaction depends linearly on the concentration of A and B. If either of concentration of A or B is double, the rate would be double. Hence, the option B is correct option. Here, option A is not correct because if we increase or double concentration of both A and B, then the rate would be increases by factor 4. Hence, option B is the correct option. Option B is the correct option. That is, concentration of A is double and concentration B is kept constant. So next, the order of the reaction for which the unit of rate constant are mole per dm cube per second is, and the correct option is option C, that is 0. So let's see the explanation. We have the formula for the unit is equal to concentration divided by time into 1 divided by concentration raised to n, where n is equal to order of the reaction. So first we have to check, that is, we know that the concentration is expressed in mole per dm cube and time is generally expressed in second. So we take n is equal to 1, that is for 0 order reaction. We have to check. So unit is equal to mole per dm cube divided by second into 1 divided by mole per dm cube raised to 0. So all of you know that raised to 0 is nothing but 1. So unit is equal to mole per dm cube divided by second into 1 divided by 1. That is, we have mole per dm cube divided by second, that is mole per dm cube per second. So the correct option is option C, that is 0 order reaction. We have rate constant unit is mole per dm cube per second. So next, means the order of the reaction is 0. So next, the rate constant for the reaction twice N2O5 gas gives twice N2O4 gas plus O2 gas is 4.98 into 10 raised to minus 4 second inverse. The order of the reaction is, and these are the options. The correct option is option B, that is 1. So let's see the explanation for this question. So again, we know that the formula for unit is equal to concentration divided by time into 1 divided by concentration raised to n, where n is equal to order of the reaction. So take n is equal to 1, and we know that the concentration is generally expressed in mole per dm cube or mole per liter and time in second. So unit is equal to mole per dm cube divided by second into 1 divided by mole per dm cube raised to 1. So we have mole per dm cube divided by second into 1 divided by mole per dm cube. So mole per dm cube being cancelled. So we have only unit is equal to second inverse, because this denominator second is goes in numerator. So we have plus 1, here is going to minus 1. So unit is second inverse. Hence the order of the given reaction is 1. So next question is, the time required for 90% completion of the certain first order reaction is T. The time required for 99.9% completion of the reaction will be, and these are the options for the question, and the correct option is option D, that is 3T. So let's see the explanation for this question. So we know that the rate equation for rate constant for the first order reaction is K is equal to 2.303 divided by T into log of A divided by A minus X to the base 10. So we know that A is nothing but the initial amount of the reactant, and A minus X be the amount of reactant present after time T. So for time T is equal T1 is equal to T, we have 90% reaction completed. So we get here there are percentage are given, so A is equal to 100 and A minus is equal to 10, because 90% of the reaction will be completed, so only 10% reactant will be remaining at time T. And for time T2 is equal to question mark, we have to find out it. 99.9% completion reaction completed, so we get A is equal to again 100%, that is 100, and A minus X is equal to 0.1%. So we have from equation 1 we get K is equal to 2.303 divided by T1 into log of 10 100 divided by 10 to the base 10, and K is equal to 2.303 divided by T log of 100 divided by 0.1 to the base 10. So equating these two equations, we get 2.303 divided by T log of 100 divided by 10 to the base 10 is equal to 2.303 divided by T2 log of 100 divided by 0.1. So 2.303 and 2.303 being cancelled. So we get 1 divided by T log of 10, because 100 divided by 10 we get 10, and 1 divided by T2 is equal to 1000, because we have to divide 100 by 0.1, so we get 1000. So we get 1 divided by T into 1, because log of 10 to the base 10 is equal to 1, and log of 1000 to the base 10 is equal to 3. So we get 1 divided by T into 1 is equal to 1 divided by T2 into 3. So T2 is equal to 3T. By rearranging the equation, we get T2 is equal to 3T. So the correct option is option D, that is 3T. So next, slope of the graph ln of concentration of A T versus T for first order reaction is, and these are the options for the equation, and the correct option is option A, that is minus K. So let's see the explanation. So we have for first order reaction, the equation is ln of concentration of AT minus ln of concentration of A0 is equal to minus KT. That is, rearranging the equation, we get ln of concentration of AT is equal to minus KT plus ln of concentration of A0. This equation is similar to the equation of straight line, that is y is equal to mx plus c, and here y is equal to, by comparing these two equations, we get y is equal to ln of concentration of A T, x is equal to T, m is equal to minus k, and c is equal to ln of concentration of A0. Here m is equal to slope of this straight line. So when we plot graph of ln of concentration of AT versus T, the slope is minus k. Hence the correct option is option A, that is minus k. So next, what is the half-life of first order reaction if time required to decrease concentration of reactant from 0.8 molar to 0.2 molar is 12 hours. We have to find out the half-life, and we have given that initial concentration, final concentration, and the time over which the changes occurs. And these are the options, and the correct option is option D, that is 6 hours. The correct option is D. So here is the explanation. First we have to determine the rate constant for the equation. We know that for first order reaction, K is equal to 2.303 divided by T log of concentration of A0 divided by concentration of AT to the base 10. So we have T is equal to 12 hour, A0 is equal to 0.8 hour, 0.8, A is equal to 0.8 molar, concentration of AT is equal to 0.2 molar. So by substituting the value, we get K is equal to 2.303 divided by 12 hour into log of 0.8 molar divided by 0.2 molar to the base 10. So by simplifying, we get K is equal to 2.303 divided by 12 hour into log of 4. So log of 4 is nothing but or is equal to 0.6021. So K is equal to 2.303 into 0.6021 divided by 12 hour. Now we have to calculate these values, or we have to solve this by using logarithm. So we have log of 2.303 is equal to its characteristics is 0, and log of 23 in 0 to 0 and 3 is 3623. Here is the multiplication. Here is the multiplications in these two values. So we have to plus log of 0.6021. 0.6021 has -1 characteristics and log is 7797. So by adding this we get 0.1420, and now we have to subtract log of 12 from this value. So log of 12 is equal to, it has characteristic +1 and log is 0.792. By subtracting this value we get bar 1 0.608, and by calculating the antilog for this value we get the antilog for this value is 0.1150. So the rate constant is K is equal to 0.1150 hour inverse. This. So next is we have to calculate half-life. So the half-life of first order reaction is given by T half is equal to 0.693 divided by K. Here T half is equal to half-life of the first order reaction, and K is the rate constant of the first order reaction. So we have K is equal to 0.1150 hour inverse. So by substituting the values of K in the equation 2 we get T half is equal to 0.693 divided by 0.1150 hour inverse. Now we have to doing the calculations for this ratio by using logarithm. Again, log of 0.693 is equal to bar 1.8407. Here there is division, so we have to subtract log of 0.1150. So log of 0.1150 is bar 1.0607, and subtracting these two values we get 0.7800. So antilog of this value is 6.076. Hence the half-life of the given reaction is 6 hours, and the correct option is option D. So next, the reaction 3ClO minus gives ClO3 minus plus twice Cl minus occurs in two steps, and first step is 2ClO minus gives ClO2 minus, and second step is ClO2 minus plus ClO minus gives ClO3 minus plus Cl minus. The reaction intermediate is, and these are the options, and the correct option is option B, that is ClO2 minus. ClO2 minus, this is the intermediate for this reaction. So let's see the explanation. We know that the species which is formed in one step and consumed in the subsequent step is called as intermediate. Since ClO2 minus is formed in one step, here ClO2 minus is formed in first step, and which is consumed in the second step, and is consumed in second step, hence ClO2 minus is an intermediate. You must remember that intermediate does not appear in the overall reaction. So here the correct option is option B, that is ClO2 minus is the intermediate. So next, the elementary reaction. O3 gas plus O gas gives twice O2 gas each, and these are the options for this question, and the correct option is option C, that is bimolecular and second order reaction. So let's see the explanation. Since the given reaction is an elementary reaction, so we know that for elementary reaction the rate is directly proportional to the molar concentration of the reactant raised to their stoichiometric coefficient in balanced chemical equation. So for elementary reaction, the order of reaction is equal to the sum of powers of the concentration terms of the reactant appear in the rate equation. So rate law for the given elementary reaction is K is equal to K into concentration of O3 into concentration of O. Here the power is 1 and here is power is 1 because here there are 1 mole of O3 is taking part of the reaction and 1 mole of O is taking in the part reaction, and this is the elementary reaction. So for elementary reaction, the powers in the rate law has equal to or equal to stoichiometric coefficient of the reactants. So rate is equal to K into concentration of O3 raised to 1 into concentration of O raised to 1. So here order is nothing but 1 plus 1, that is 2, second order. Since the number of reactant molecule taking part in chemical reaction is called molecular of the reaction. So in the given reaction, 1 mole of O3 and 1 mole of O taking part in the reaction. Hence the molecularity is equal to 1 plus 1, that is 2, that is bimolecular. Hence the elementary reaction, given elementary reaction is bimolecular and second order reaction. The correct option is option C. So next, rate law for the reaction twice NO plus Cl2 gives twice NO2 is rate is equal to this, and thus K would be increases if with, and these are the options. So option is option D, that is increase of concentration of both Cl2 and NO. Note that the rate of reaction given is incorrect, that is there is printing mistake. Here there is only NO2. So here is here are given that NO2, but there is only NO is present. The rate law depends only on the NO and Cl2. Hence the correct rate law is rate is equal to K into concentration of NO raised to 2 into concentration of Cl2. So remember here there is printing mistake, that is there are NO2, but instead of NO2 there is only NO. So let's see, the rate of the reaction is given as, that is correct rate law is rate is equal to K into concentration of NO raised to 2 into concentration of Cl2. The rate equation implies that the rate of the reaction is linearly depends on the both NO and Cl2, and hence the rate of the reaction increases with increase in concentration of both Cl2 and NO. So the correct option is option D. So next, for an endothermic reaction, X is in equilibrium with Y if E forward is activation energy of the forward reaction and ER is that of reverse reaction. Which of the following is the correct? And these are the options for this question. And the correct option is option C, that is E forward is greater than E reverse. So here is the explanation. Given endothermic reaction is, here the reaction is in equilibrium and which is endothermic in forward direction. Remember, the reaction is in equilibrium and is forward and is endothermic in forward direction. Since forward direction is endothermic, hence it requires more energy to attain a transition state. Hence it requires more energy to attain a transition state, and backward reaction is exothermic. It requires relatively less energy to attain a transition state. So EF is greater than ER. Hence EF is greater than ER, that is E forward is greater than E reverse. So questions are over. I hope you like the video and enjoy the video. Thank you. Thank you very much.